In this video, we are going to discuss how to design a standalone system or an off-grid system using a program called PVSyst. So in this course, we are going to use PVSyst 6.4. Okay, there is a newer version which is 6.7, but you will not find large differences between them. Okay, so starting with PVSyst, we will double click on it. And you will see here, first you will choose preliminary design or project design or database or tools. So we are going first to choose our project design. Then you will find here your own system. Is it a grid connected system or a standalone system or a pumping system or a solar system? Pumps you are working using solar energy, or a DC grid if you are talking about a grid working with a DC voltage or DC power. Okay, now we are going, in this video we are going to design the standalone system. So we'll click on standalone system. Now we will find here the first thing is that we will write our project name. So my own project called a standalone project at Al-Maadi, where I live. Okay, the date is 2/1/2019. Okay, now we will see that the first thing that the program tells you to do, and you will find here something in red color. This means that the program is telling you to do this, or this is the thing you have to do. It tells you please define the plan orientation. So let's see how to define the plan orientation. We will simply first click on orientation, but before we start doing this, we have to choose our site. So our site and menu, you will find here, for example, you will choose your own country. For example, here I am choosing Egypt, and you'll find here your own government. For example, I am living in Cairo, so I can click on Cairo and it will give you the data for Cairo. Okay, now if I would like to create my own place, or be more specific, not Cairo or government of Cairo, I would like to be more specific about the place where my own house is located, or my own PV system located. So I'll click on cancel, then this one, and go to databases. Okay, if I click on databases, you will find here geographical sites, and you'll find here your own country. Okay, you will find here Cairo or Egypt, sorry. Okay, and you will find here different data, the data which is, or the data which appeared before. Now I click on new. Then I would like to add another location according to my own place, okay, or my own latitude and longitude. Okay, so if you open this, you will find here a map, and you can put here the latitude and the longitude and click on it to be, or to put a new site. But another method, instead of waiting for this to download, we can click on geographical coordinates, and we say that our site called Al-Maadi in the country Egypt, region Africa. Okay, now I would like to put the latitude and longitude of my own place. So what I'm going to do is I'm going to go to this website called Power Data Access Viewer. You will find the link in the slides. Okay, this is provided by NASA. Now what I'm going to do is that I go here and zoom in this area by double clicking. Let's zoom in again. I just keep clicking, double click in order to zoom in this map. Okay, now for example here I'm going to choose for example here this point. Okay, now I would like to select this point and find its magnitude and latitude. So I will click on this point, okay, and then go here and click here. Okay, so now you will find for this point, you will find is the latitude. Okay, now I'm going to the program again and Control V like this. Now for the other one, copy the longitude, Control V. Now we would like to find the altitude, how many meters is our place above sea level. So we can click here and then type Cairo. Okay, altitude, okay, above sea level, I think it is 23 meter. So I will type here 23. Now my own time zone, so I will say Cairo time zone +2. So I will click here 2. Now I define the latitude, longitude, altitude, and time zone of my own place. Now I'm going to have two data or two places where can I import my own data. You will see here that here, please import the monthly meteo data from Meteonorm or NASA. Okay, or manually. So I will choose the database of the program itself and then click on import. Now you will see that for our site called Al-Maadi, you will find here for January, February, March, April, and the months of the year, you will find kilowatt hour per meter square months. Okay, so the amount of energy generated per the meter square in 1 month. So I'll find for 1 meter square kilowatt hour for January, for February, and so on. And you find here the different temperature, the wind speed, and so on. This data or these data are provided by the program itself. Now I'm going to click on OK. And then I will type the file name. So I will click on Save. Is now saved on the database. And then click on OK. Yes. Save. Okay, and you'll find here the geographical site now is added to our database. Now I click on close and get back to our program. So I will close this one, project design, a standalone system, standalone project at Al-Maadi, and then I will choose a site. So I will choose my own site, which is Al-Maadi here. Okay, and then click on OK. You have modified the project. Please save it before calculation. Save project, save. Now please define the plan orientation. So we'll go to orientation. Now you will find here this represents the tilt angle where our panel is the angle between it and the horizontal. Okay, so for my own country, the recommended angle is 30 degree and azimuth equal to 0. Azimuth, what does azimuth mean? You will see here that if the panel is like this, in the perpendicular to the south direction, if I increase this one to 50 degree, for example, you will see that the panel will be inclined by an angle 15 degree with respect to the west. Okay, if I increase it to 90 degree, it will be like this. Okay, so this represents east, west, south, and north. So the angle here is between the panel and the west, or the west or plus 90 degree. Now, if I would like to optimize our output according to yearly radiation yield, because I would like to, would you like to optimize the angle for the yearly, or for summer only, or for winter? Okay, so I will choose yearly because I would like to optimize my own uh, PV system throughout the year. Okay, or if you are using the PV system only in the summer, therefore I will choose this one. If I am optimizing it for winter from October to March, then I will click on this one. But I would like to optimize throughout the year. Okay, now I would like to find the effect of changing the tilt angle on the VI curve. So you will click on show optimization, and you'll find here this represents the change of uh, the power with respect to the tilt angle. So if I change this one as I increase it, okay, you will find here that the power at 44 degree is decreasing. Okay, so in order to optimize, we have to put it in this point. So at 30, okay, you will find here that it's optimized. If it changes the azimuth, you will find also here that the plane orientation it changed, of course. Okay, 20 degree and so on. So the orientation also it changes the power. So we'll keep it 0 here to optimize the maximum value, and here for 30 degree to have the maximum also value. Now you will find here the field type, of course, fixed, or you would like here, for example, tracking vertical axis, moving in the vertical axis, or it's moving in the horizontal axis, dual mode, or having two direction on the horizontal east to west, or horizontal north south, tracking two axes, and there is a difference type here. Okay, but now we are going to choose the fixed tilted plane. Okay, now we would like to optimize by year, then we click on OK. Now users needs not defined. With a standalone system, you have to define the valid on zero user needs. Okay, so what does it mean? It means that we need to define our load. So I will click on user needs, and you will see here that lamps, TV, PC, mobile, domestic appliances, fridge, deep freeze, dish and clothes washers, and so on. So we will have our example which we did before on the manual calculations. For a standalone system, we are going to have a load of air conditioner 2500 watt. So I'm going to add one domestic appliances, which is the 2500 watt. Okay, now leave this hour alone. Okay, now for the fridge, 200 watt for 24 hours. So the fridge 200 watt for 24 hours. But just a note here that the value is kilowatt hour per day. So kilowatt hour is 200 multiplied by 24, which is 4.8 kilowatt. Okay, now TV 200 watt, one TV 200 watt for 2 hours. Okay, now leave it now. 5 lamps each of 60 watt. So we'll choose here 5 lamps 60 watt. Okay, and for 2 hours. Okay, now leave this hour alone, and I will tell you why. Now you will see that here the appliance 1, please define the hourly distribution, the second page. So we'll see here that we have here second page, which is called hourly distribution. So we'll see here that what does it mean. For the fridge, it is working for 24 hours. So the total hours 24, and all of the field is completed. Now our lamp for example, is working for 12 hours. So the hours are from when are you using the lamps. Okay, I'm using the lamps here from for example 6 p.m. to 6 a.m. Okay, 6 p.m. to 6 a.m. So it means that I am according to the world clock from 18 to 6 hour. Okay, so for the lamp I will just right click here, right click like this, right click and move, right click and move. Okay, now our lamp is working for 12 hours from hour 18 to hour 6, hour 18 to hour 6. Okay, from 6 p.m. to 6 a.m. Now for the TV or PC, 200 watt for 2 hours. Okay, so 200 watt for 2 hours. Now for 2 hours, I will assume that I'm using TV from 18 to 20 to 20. Okay, you will see here that's 3 hours. So if I would like to delete, I will just right click. Okay, if I would like to add, then I will left click. Okay, left click to add, right click to move. Okay, now the domestic appliances, which is the air conditioner for 8 hours. I will assume that air conditioner is working from 12 p.m. to 8 p.m. So from here for 8 hours. Okay, so from 12 p.m. to 8 p.m. Okay, now I have defined my own loads and their consumption time and their hours in the day. Now you will see that here there is no message here, and then we can click on OK. Now we will find here that system definitions battery model is not defined. Okay, so we need to find the battery. Now if I click on system, now we will find that the program automatically suggested 96 volt. Okay, this is a value suggested by the program. Okay, now here you will find another value called LOL, or loss of load. It means that the period or the time of the day where we don't have our battery, or when our battery is not charged. Okay, so we'll keep it 5% of the day. Enter the requested autonomy. Autonomy is where the or when the days when our power is not available. So you have to remember that each day multiplies the number of batteries. So assume just one day without power. Okay, now you will see here that battery user voltage 96 volt, and the suggested PV power by the program 8.11. Okay, this is a suggested value. Now you will find 96 volt is the same value which we obtained here, right, during our design. Here our battery, we assumed 96 volt. Okay, same as here. Now you will find here that we can choose our batteries by voltage, capacity, or manufacturer. Now you will find here according to manufacturer, we have a different companies here which sells the battery. Okay, now I will say all and then search for a good one. Okay, we said that we can choose here 12 batteries, same as we did here, but I'm going to choose and find according to their own power. Okay, I need at least 200 ampere hour. Okay, this is my own design. Okay, you can choose a higher value which changes the design. Okay, 200 ampere is not a must. You can change it to 300 ampere, which means lower number of batteries, or you can change it to 150 ampere, which means a higher number of batteries. Okay, So this is according to your own design. So now I need 200 ampere. So this one is a 6 volt, 200 ampere. Okay, now no, I need a higher value with a higher voltage. Okay, this one is 196 12 volt. Okay, so we'll see that the program suggests that batteries in series, we need 8 batteries in series and 2 batteries in parallel, or 2 strings. Okay, so 8 batteries in series parallel with another 8. Okay, simple as this. So total number of batteries is 16, same as the manual calculations which we did before. Okay, 8 batteries in series. Why? Because 8 multiplied by 12 volt will give us 96 volt. Okay, now you'll find here operating battery temperature, if it is fixed or you can change it. Okay, so for now I will keep it as a fixed temperature. Okay, now let's see the second thing, which is please choose the PV module. Okay, from PV array, okay, we will go to choose the PV module. Select the PV module. So you'll find here all modules, which is all of them, or which are available on 2015. I will choose all modules, okay, to see everything. Now you will see here that here we have a different companies for PV cells. Okay, there is a Schneider, EPP, LG, and many companies. Okay, so according to the company available in your own market, you can choose between them. So I'm going to choose an LG, for example. Now I would like to choose a PV module. Okay, now we can choose we choose here in our example 230 watt, as I remember. Let's see. Mm, 250 watt. Okay, so let's see what is available here. If we have 250 watt, yes, we have here one. We will choose this one. Okay, you will find here that the program shows this is that we can have 5 modules in series and 6 strings, which means we have a total of 30 panel. Remember that the suggested power here is higher, 8.11, but here we have only 7 kilowatt. That's why the program suggests we have 5 multiplied by 6, or 30 values. And you'll find here that it will give you a suggestion should be between 6 and 7. So number of strings can be 6 or can be 7. Okay, now we will find here that 5 multiplied by 6 will give us a total output power here, nominal power at STC 7.5 kilowatt peak, but the power at 1000 watt per meter square and 50 Celsius degree is 6.6. Okay, now what we are going to do is that please choose the controller module. What does mean controller? It means the inverter here. Okay, now we will find here that let's choose any company we have here. We have a lot of companies here. For example, I'm going to choose somewhere. Let's see here. Okay, now automatically we will see that the battery voltage is 96 volt. Okay, so when I selected 12 volt here, it tells you the control output voltage does not match the battery pack voltage. Okay, because this one is at 12 volt and the battery voltage is 96 volt, so I have to choose another one. Now I would like to choose all manufacturers to see what is I have or what I have in the market, and you'll find here 96 volt. Okay, 76 ampere, same as or nearly as we chose here. Okay, this module you'll find here 96 volt, 60, 60, 48. We chose 96 volt, same as the battery here 96 volt. Okay, now there is another message here saying the controller power is strongly undersized. So what does it mean? It means that you will see that the power of the PV is 8.11 kilowatt peak, but you will find here that the power of the controller is 720 watt. So this is a very low power. So what I'm going to do is that I will try to find another one with a bigger value of kilowatt. Okay. So what I'm going to do here is that I will click on universal controller. Okay. You'll find that the program itself choose a module or a inverter with automatically, okay, 96 volt, 38 ampere, 6 amp, and you'll find here that the module in series is 4 and number of strings is 8. This will give us a nominal power of 8 kilowatt peak. Okay, number of modules here is 32, different from here 28. Why? Because the power here is 7 kilowatt, but here is at least 8 kilowatt peak. Okay, now we will click on OK. Now we find all of this are green. Okay, so we can start our simulation. So if I click on simulation and then click on simulation, then click on OK, then we click on report. Now we will find here the final data for the simulation. You will find here the project name, the latitude, the longitude, the country, everything you would like to take when you are going to buy the components for the PV system. You'll find here the type of the modules, mono module. You will find the number of modules in series, in number of parallel strings, number of modules, the nominal power at STC, the power at operating condition, the module area, okay, which is required, a standalone system, and different things. Okay, you will find here at page number 2 the hourly consumption according to your own load, each load and its own energy. Here at page number 3 you will find here different data. For example, the available energy from the PV system is 13.57 megawatt hour per year. Let's see page number 4. You'll find here a loss diagram representing the losses inside our system. For example, losses due to radiance level, losses due to temperature, module array mismatch, ohmic wiring losses, losses in the wires, module quality loss, losses due to the quality of the module, converter losses during the conversion, battery losses, and different things. Okay, so this one can be you can print this one and use it to build your own PV system. So this how we design our PV system or standalone system using PVSyst.